Well, you'll notice a little logo up there. It's a little misleading because you know there's no lion in statistics. Well, anyway, I'd like to talk a little bit about this package. I presented this at Dyalog15 in Eastbourne, and I've done a lot of work on it over the past year. And I'm using it in my course this year. So a little bit of the motivation here. Basically, I've designed this to be used as a 1 or 2 semester statistics course. And since we're using the software, it allows you to cover a lot more material than you would if you had to do it manually or even using some other software packages. TamStat combines features of other statistical programs like Minitab and simulation programs like there's one that we use called Crystal Ball. So I've kind of merged them into one package. And the unique syntax, I use APL operator syntax to do a lot of the work, which makes this product unique from other statistical packages. Basically, I'm not going to go into as much detail into the inner workings of TamStat because, as I did last time, but if you're interested in learning more about it, I'm thinking about doing a workshop on this, and if you're interested in that, put that on your comments. If you write it in your comment sheet in the Dyalog comment sheet that you turn in at the end of the day, let them know if you're interested, because I'd certainly be happy to do a workshop on this and go into more detail about it. But I'm going to show you just a brief example of some of the things that can happen. Statistics deals primarily with 4 types of functions, and descriptive statistics is the first part where we summarize data. You take a data set, you take a variable, and you try to summarize it with a single value. We also deal with probability distributions, and there's lots of those, but they're all basically the same structurally. We deal with relations such as greater than, less than, membership, and things like that, and logic, and, or, and if. So those are the 4 basic types of functions that we deal with, and we use operators to combine things together. Here's an example of a problem. A movie theater has 130 seats. Movie attendance average is 100 people with a standard deviation of 20. What is the probability that the theater will have to turn people away? Well, this is a classic business problem. So let's compare other programs versus TamStat. By the way, TamStat stands for Taming Statistics. That's where the name came from, so that's why we had the lion tamer up there. And I got the idea from, I think Ken Iverson presented a paper on taming mathematics and using APL notation to, instead of subscripts and superscripts and all kinds of crazy notation. So I sort of hijacked that from him. So anyway, so the movie theater problem, let's go back to that. In Excel, you would type norm.dist, and then you would have to indicate 130 is the capacity, 100 is the mean, 20 is the standard deviation, and then you would have to say, oh, this has to be cumulative distribution, not the height of the curve, the height of the normal curve. So it would not be the value of the density function. So you have to indicate that. And then after you're all done, since we're looking at the upper tail of the distribution, you have to subtract the result from 1. Well, it's not a big deal, but it's a lot of times you're looking at the upper tail more often than the lower tail, so you want to be able to deal with that. In R, similar, they have a function called pnorm. And again, you put 130, 120, and then you have to say lower dot tail equals false. If, on the other hand, you want to use Minitab, that's all menu-driven, and you'll get a screen up. I won't bother to go into it, but you have to put in the same information, and it doesn't have a lower tail equals false indicator there, so you have to subtract a result from 1. Okay? Again, it's not a big deal, but it's a little annoying. It would be nice if you could just type something in like this. And this is the way we do it in TamStat. You say 120, which is the mean and standard deviation of the distribution. You say normal probability greater than 130. And that reads very English-like. It's fairly easy to understand. And guess what? We can write that as a dyadic operator. So we have probability is the dyadic operator. The operand is normal, which is the distribution. The left argument are the parameters of the normal distribution. And the right operand is a symbol which can be greater than, less than, greater than or equal to, less than or equal to, equals. And then the right argument is the value, the capacity of the theater, for example, the value we're interested in. Now here you'll notice that greater than or equal to will give the same result for a continuous distribution like normal, but you can also apply this to discrete distributions like the binomial, where you will get two distinct answers if you use a strict inequality or a something just greater than or equal to. So that was kind of the motivation for this program. So anyway, I've been developing a lot of this stuff, and I wanted to mention a little bit about some of the new features in TamStat that I've been working on. First of all, it's great to have a program like this, but if you're going to use it in classes and you want people to use it, you got to document it. So I worked all summer on a user guide, so we have a TamStat user guide, which Jerry's going to pass that around. If you you can browse it. It's also available in a PDF form. In addition to that, I've come up with a little reference card similar to the Dyalog reference card, and it's so I did spend a lot of time working on the documentation, and I can't emphasize how important that is. The user guide is about 70 pages, and again, I mentioned it's a PDF or hard copy. And the reference card, I tried to use the similar notation that was used in the Dyalog reference card. I'm trying to be consistent. And so whether I indicate whether something is a variable or numeric or whether it's integer or floating point and stuff like that. And so again, that's available also as a PDF. Import function. Okay, a lot of students use Excel, and so basically what I've done is I've written a program that allows you to import data from a CSV file where the headings are the first row is the names of the variables and the columns are the data. So that's a standard. I think that's like a data table that Richard Proctor talked about earlier. So that would be an ideal setting for that. So you type in the function dgets import, and then you put in a path name .csv. If you just put in quote quote, you'll get a little window. You can go in and search through the directories to find the file you're looking for. There's a function in TamStat called variables, which basically lists the variables inside the data set, and then you can dot into them. So if I type in mode d.state, the state is a list of the states. This is data that I collect from the students usually at the beginning of the semester. So I say d.state. D is the namespace. It puts all the variables into a namespace, and then you dot into the namespace to get the value state, which is a vector of vectors, and then it will capture the most frequently occurring state in the list. Similarly, I could do it with a numeric variable, calculate the median, the mean, standard deviation, whatever you want. Okay, coming directly out of the data comes directly out of a CSV file. R interface. Okay, I've created an R interface that goes into R. So TamStat is like a cover function. TamStat is like a cover database for RConnect. Okay, so I've embedded RConnect into TamStat, and here's the normal function that I had written here, and basically there's a lot of code here going on, but you'll see Right over here, the code that's in red is I create a string that builds a call to the R function pnorm, and based on the left the left argument, it will calculate various normal functions, things related to the normal distribution. I have this global variable called pound.r available. If that's 0, then R is obviously not there. You'd have to install R on your computer separately. But if it is available, it will call the R function, grab the results, and then get out. Otherwise, it'll continue on. I've written all the programs in APL, so there's an APL version of everything. People trust R, so this way, if you know you're using R, you don't have to. If you don't trust my code, you can know you're getting R. On the other hand, most of mine works, but there are some extreme cases which I haven't flushed out yet, and so then you can use R to get out the results. Okay, last year somebody I forget who it was, but they asked me if I'd done anything with Bayesian statistics, and I said no, not at the time, but I would look into it. So this is sort of an answer to that person. I'm not sure if he's in the audience. Bayesian statistics. So this is a problem that I think Paul Grosvenor from Optima would also appreciate. In drug trials, well, actually in tests, let's say that there's a test out there for cancer, and you take the test and it comes up positive, and do you have cancer if the test comes up positive, basically? So here we have we set the prior probabilities in Bayesian statistics. So we have a two-item vector, the probability that you have cancer and the probability that you don't have cancer. Now we set the conditional probabilities here. Given that the test comes out positive, what's the probability you have cancer? 90%. And the probability that the test is positive and you don't have cancer is only 2%. So let's say you take the test and it comes out positive. What's the probability you have cancer? This is an example of Bayesian statistics where you're reversing the conditioning. Well, the answer to this question is quite surprising. So in order to find the Bayesian probabilities, you can use a fork or a 3-train. And I thought this was really kind of cool. So I wrote this function called Bayes, and basically it's times divided by plus dot times. So what I do is I take prior Bayes, the function Bayes takes on the left prior and it takes the condition values, and it gives you the probability that you have cancer, which is 58.9%, and the probability you don't have cancer is surprisingly 41%. So you would think that if your test comes out positive, given these probabilities, that's what you would get. So this is another example of a program that's in TamStat. Okay, so I thought that was an interesting use of some of the new functionality in Dyalog15. Okay. Yes, you can assign any length, and it will give you all the probabilities. Now, I've developed basically 3 versions of TamStat are available, and I want to talk about that. First of all, I've created a Dyalog workspace, which is basically there for APL users, and basically it's just a workspace, and you can combine it with whatever you want to do. I also created a standalone app. It's just an exe file, which basically has a thinly veiled cover on it. and it's designed for people that don't have APL, for particularly a lot of my students that are out there. And basically, I've made a few substitutions that they can type in ASCII characters, but it's just an app, and no installation required. You just download it and run it. And so, if I have time, I can show you a quick demo of it. But I just wanted to mention that. And then finally, we have a web app similar to TryAPL, which uses MiServer, and Jerry developed that, and he's going to be talking about that in a bit. In addition, we at the Carlisle group are developing a program called FlipDB, and basically there's so this is kind of like the fourth app, but it's still in development. This is a professional version, which would be used. This would be used by professional people in, say, in the mortgage industry, and but the same syntax of the functions will be available. So getting back to the TamStat app, I did make a few ASCII substitutions since they may not have access to the APL character set. So I'd use less than dash for assignment, which is actually I think what R uses, believe it or not. And then less than or equals, not equals, and so on. Again, it's a single .exe file, bound executable. I've also given them a choice of fonts. So if they have the APL font, they can use it. If they don't, they can use another font to display the result. So that's about all I have. So I'm going to, Jerry is now going to talk about his version of using MiServer. So, Jerry, I'll turn it over to you.
Okay. My name's Jerry Brennan. I'm from Hawaii, and I started out teaching statistics for about 10 years at the University of Hawaii, and then I switched over to being a psychologist in private practice. So I'm part logical and part psycho, and I just want to let you know that. And actually, we all are. And so one of my goals has been to help people be logical when I was teaching statistics, and now I'm a psychologist still helping people try to be logical because there's a lot of logical unreasoning. I have an example for you, a quick one. How many people have ever had somebody make you angry? Can you raise your hand? Okay. Okay, you're all crazy. Okay, it isn't true. What happened is somebody did something, and you thought, they shouldn't have done that. That wasn't right. And that's what made you angry, is your own thoughts. Nobody else makes you angry. You make yourself angry by the way you think about what they've done. Okay, so you're all nuts. So we're all together on this one. Okay. But anyway, this is one of my goals, is to try to wake people up. And statistics is very, very helpful in helping people understand things. As the example he just gave with the Bayesian statistics, it isn't exactly what you thought. You know, you get a positive test for cancer. You go, oh my God, it's over. Well, it probably isn't. Maybe only 60% of the time it is, but 40% of the time it's wrong, even though, you know. So anyway, I've developed a website that I'm interested in teaching these logical skills to kids mostly now, students, high school students, and so forth. I've developed a web page called jmbaplcloud.com, and if you go to that web page, there's a bunch of lessons, and I've included Steve's TamStat package in there, and I've tried to package it in a way that's easy to use online. You can import data into it and do analysis, and I want to show you some of that, and also show you some of the more general stuff that's in the package. Okay, let's see here. Okay, so this is the front page of my MiServer page. I'm still using the older MiServer, and I need to make this more beautiful, but Ryan's going to help me with a little bit of that shortly. But it gets the job done very well, and I'm very pleased to have it. So if you take a look at this, I have two goals. One is to help with statistics and logical reasoning, but also I think programming APL. I think APL is an incredible language that's enabled me to do all kinds of things. I have written 150 psychological tests programmed in APL to administer to people to help me in my practice, and it helped me all the way through graduate school because I could analyze all my professors' data. They couldn't possibly give me bad grades and so forth. So it's been very, very helpful to me. I also, while I was getting my PhD, I analyzed data for 100 fellow students, so they got their PhDs written, and it just was very satisfying to help people. I've enjoyed helping people all my life. Anyway, so right here I have a thing called Download PDF. I also have a manual. It's about 60 pages of examples, little programming examples, sort of introduction to APL, some games and some sort. I'll show you some of that as we go through, but that's a download. So if you go to the web page, you can download that PDF. Down below are some little buttons down here that show some intros into APL, where you can watch some of the videos that we have about APL, and I have some very introductory lessons there. There's a mathematics section, which I'll show you some of. Statistics, which includes the TamStat, which I'll be showing you some, and some games and so forth to entice kids into learning APL. Okay. So, that's the code that writes that first web page. Another thing that I like about MiServer is you can click on that thing in the upper left-hand corner and see the code that creates the page. And I'm interested in teaching programming, and programming has got to be on the web these days, really. So this is a fairly easy way, and I can teach kids how I wrote the web page that's teaching them. So here is the table of contents to my 60-page little book teaching different things. APL, they're all APL examples. If you take a look up here, I have a little exercise called the order of precedence. I'm going to have one more quiz for you after the last one. We'll take a look at that one, hopefully. There's some stuff about predicting the stock market, and I'll show you a little bit of that. Some mortgage calculations, polynomial analysis, quadratic equations, basic statistics, the kind of stuff that high school students need. I'm trying to show them you can do this with APL. It helped me get through school and can help them get through school. Let's see what else. Another really important one is this alien attack thing here. You didn't probably know, but the aliens are attacking the Earth, and we need to get some guns. How many guns do we need to shoot down the ships? I wrote a little prototype program to do that, and then I let them fiddle with it and improve it so that we can make sure that we all survive. That was a very engaging exercise. You've got to find things that attract people in the beginning, and that was one that worked quite well. I have another thing called stylometry. I'll show you a little bit about that in a minute. How many people know what stylometry is? Hey, there's one. Okay. So it takes text documents and analyzes them. Did Shakespeare write this, or did somebody else? Is this a forgery? And so forth. So you can take text and analyze it, see what the word lengths are, the sentence lengths, what kind of connective words are used, and so forth. Very simple to do in APL, and kind of an intriguing question that so kids can analyze their stuff and see if they've can write like Mark Twain does, or if they're more like Mary Shelley or so forth. So let's see here. So anyway, all of these are examples. They're brief. If you look at the 60 pages, I think there's about 35 different chapters there, showing a little bit of APL, a few lines that do some magical stuff. They're all designed to be starters, but not finishes. So they can they can begin playing with it. All of this stuff is also available on the website, so they can put this on one side and the website on the other and drag things across and execute them all. Okay, so here is my main everything web page, and you can see some of them. Like here's that match one to the programming thing, and the graphics and all that kind of stuff is in here. Down here is the taming statistics one. I put a little red mark by that. I have an adaptive vocabulary test down at the bottom that I can, 15 questions, tell you how smart you are, vocabulary-wise anyway, by adapting. How many people know what adaptive testing is? Got a few people here that know about that. So basically I ask you a middle-level vocabulary question. If you get it right, there's no point in asking you any questions that are easier than that one, so I don't. I just ask a harder one. If you get that right, I move up to a harder one. If you get that wrong, I drop down. 15 questions, I can pretty well tell your vocabulary level from pre-kindergarten to IQ, genius IQ level. All tests should be done that way. Students love that when I talk about it because they're tired of taking those long tests. So anyway, let's move along. Here is another page that focuses on the more statistical and data analysts, analytical kinds of things. And down at the bottom is the Taming Statistics. And here is the first page from Steve's incredible statistics package here. And if you look here, I have Taming Statistics, and there's a bunch of tabs. And each of the tabs has an example or something to do on it, a practice problem that you can run through with. Down below this section down here, and there's a little input line where you can input your APL and run the thing. So you can do all the examples right here without referring to anything else. But there is a lot of documentation that Stephen's produced. Here's 4 different documents of his calculations, and there's a reference card, inferential statistics, and then the user's guide that you folks is being passed around. And where is that thing anyway? It's that way. Should we put another one out there? Start one at the back or something, so we get everybody to get a look at that before we're out of time. So down here are all the APL symbols, so you can drag them down to this little line here. I'm hoping to improve that interface a little bit, but it works. And so you can do any APL code there using the APL symbols. And let's move along. So here I've gone over to one of the other tabs. Well, let's see here. I'll make sure here. Let's go back one more. Right down here, you can click and download a sample data set. You can also read data into this package, of course. And here is a sample data set right here that is examples that are in the textbook. So that all of the examples in the textbook can be run online and tested and fiddled with and experimented with. And I'm a big believer in noodling and fiddling and whatever. I think you learn a lot more than just doing the odd questions at the end of the chapter. You know, poking around is the way you really learn things. So that's available there. And I have a little import thing down here. We can choose a file and import it in to my package. Okay. So anyway, here's one of the tabs called a paired t-test. I've highlighted some stuff up here. So here's we have a group of students who've watched a video, and before they watched the video on calculus, they took a test. Then they watched the video, took the test again, and we see if they learned anything from watching the video. So we have their pre-scores, their post-scores, and this little APL line mean, so I can get it to print out their averages. So if I drag each of those lines down here and hit the calc button, it does the calculations. And I've shown the last one here. I have a 0.05 difference mean hypothesis, and it's down here. I hit the calc button, and this is the report that's produced. And the difference here is 2 points. So the students averaged increase of 2 points. Okay, pre and post. And that is statistically significant, and we can reject the null hypothesis down here. However, 2 points maybe isn't a whole lot. Again, we got to be careful with our statistics. There's a lot to think about, and I think we'll add a little bit more to this thing to do that. Thank you. Now I've jumped over to a regression tab here, and this does a regression analysis. Now in this one, I did import some data, that sample data set, and I chose file name, and it imported this thing called file example data CSV. It's a CSV file. I can read any CSV file or any text file where you put a couple variable names at the top, so you can construct your own things. And there's a tremendous amount of data out there. So anyway, this imported things into a namespace called D, and the variables that came in are listed over here. So you just click the button, data's brought in, and all set up for you. And then I asked for a regression report, so regression analysis setting shoe size, height, and the student ID number. Click the calc button. So I just took this thing up here, dragged it down here, and hit the Calc button. That's all they have to do on this example page to get a feel of how to do things, and then they can do their own work. Okay? I learn well by examples, and I think other people do too, so I try to have a concrete example for everything. So here's the results here. Height is highly significant, and student ID number didn't student ID number, how's that going to predict, their shoe size? So, okay. So anyway, and my R-square here is about 68%. Now, another thing I might want to do is get a plot of it here. And so down here I have the plot thing, and if we look on the next page, we'll see the plot. And there's the linear regression plot of the data, looking at the shoe size across the bottom and the heights up here. And the correlation without the ID thing is almost exactly the same as it was before because the student ID was irrelevant. Okay. Here is my the table of contents for my examples again, and sometimes I suggest you set it up on a double page like this, and then you can just drag things from my examples over into here and execute them, so we have an easy way to learn things. Here is part of my stock market page in my book. Here's some data out there that you can read into your computer, and then you bring it into my program by just clicking here and here, and the variables come in. And down here I did a little data cleaning because there's some zeros in there because the stock market on Saturdays and Sundays isn't working, so there's just zeros in the data. So I got to get rid of them. So here's a little line of APL that gets rid of the zeros, and then I did a plot here, and this is the Dow Jones stock market for about 10 years of data. So I have that little data set, and I played with it. Can you, what days of the week are the best days to buy stocks? Anybody know? No. Well, what's that? Okay. There are certain days that are better than other days. How about which week in the month? Well, correct. Right. So anyway, with a couple, right. Well, just download my PDF. It's all in there, and the examples are in there where I take a look at days of the week, weeks of the month, months of the year, and so forth. It's very, very simple to do in APL, and I think it's an intrigue. I figured you guys would be interested in that, so I put that one. The students are also. Okay, so all you have to do is drag these lines across to here and hit the Calc button. That's all you have to do to get the numbers. Okay, so here's your next test here. Okay, so we have a clueless student faced with a pop quiz to match a list of 24 presidents with another list of 24 terms of office. Being clueless, they had to guess. Does anybody think you could do that? Match all the presidents up? No. Okay, so we got to guess. How many would we get right? Just guessing. Go ahead, guess. Everybody got an idea? What's that? 35%. Okay, we have a 35. Got any other numbers? How many people think higher than 35%? How many people think lower than 35%? Okay. How about 10%? 10%. Okay. Okay, well, anyway, I won't embarrass you further. Okay, so here's the Noodle Around page. Okay, so there are a bunch of tabs here that take a look at this thing. Okay, so we're going to noodle around here. Being clueless, I didn't know what the heck the probability was, so I thought, well, I'll just play with my APL a little bit and find out. I switched it over to a 5x5 thing here just as an example instead of 24 by 24. So if I can solve this, then it'll be easy enough to switch the numbers and get the bigger ones. So I can do 5 question 5, and that'll give me a random assortment, of the things. Okay, does that make sense? Then I can do another 5x5 for my guesses. I can compare them here. 5x5 equals 5 question 5, and there's the number matched. So I got 2 that time. Here I tried it, I didn't get any. Okay, So here I made a little, but I really want to add those numbers up, so I put a // on it. Again, this is not fancy APL, but it's a start. It's a starter. All of my lessons have little stars on them, and this is one of the 1-star lessons. Okay, I have more advanced lessons, but this is one of the very beginning ones to get people started. So basically, I have a little thing there that'll tell me the answer there. So now, let's see, we go over to the next page, and we're over here to write. I wrote a little function called present match. For present match, it's // omega question omega equals omega question omega. I could call it here present match 5, and I got none. So here I ran it 100 times, okay, and I got 0.95, so about 1. Okay, so run it again. So now let's, so I've got something that works here, and I've run it a number of times, and it looks like it's, for 5, it looks like about 1, okay? Right? So what happens when I go to the 24? Got 5 minutes left. Okay. So here I start running it. Here's the 5s called the average present match. Then I ran it 24 and I got 1. Ran it here, run 100,000 times. Okay. So run 100,000 times. I'm getting 1 all the time. So the conclusion here is study. Guessing's not going to get you very far. And learn some APL, and you can very quickly figure things out. Okay, so that's one of my little lessons. And then here's a comparison to Matlab that does the same problem. So there's my code, basically, that figures the thing out. And here's a Matlab code that is not as cool. Okay, so there's my conclusion to the students. And I mentioned that stylometry thing to you once before. There is a web page in there, and here are a bunch of, this is Mark Twain's Huckleberry Finn, 6 chapters. Here's 3 chapters from Mary Shelley's Frankenstein, and here's their average sentence length for each of the chapters, so we can see that Shelley's got longer sentences. Average word length, she's got longer words. But when we look at her vocabulary level, because I can get vocabulary levels on everybody, she's got a much lower level than Mark Twain does in using big words or advanced or difficult words. Then this is percent words. These are connective words like and, if, but, stuff like that. And you can see there are big differences there. And then this one is the positive and negative words, and you can see there's differences there. So quite a few differences in the style of writing. Here's a place here where you can choose your file and submit it, and it will analyze your text, and you can compare it to those other ones there. So this is all the code that does the stylometry thing that I showed you there. So there's a few symbols. I got to get rid of those symbols. Here's the Mark Twain, the 6 chapters, Frankenstein, the first 3 chapters. So those are the texts I'm going to analyze. These are the functions, average sentence length, word length, vocabulary. So those are the things. I put them together in this little StyleTable thing, and it does the calculation. There's a sentence length, average length, vocabulary. So I've given a bunch of little basic tools for students to begin analyzing text files. Okay, but I hope they will take it further, come up with other ideas besides the ones I have, and go somewhere with it. Here is one last one. I have another section in the book called For Fun with Numbers. Find all the 3-digit numbers, positive numbers whose digits are the same when they're added or multiplied together. So I have a bunch of little problems like that, kind of like the games thing. So I'm always looking for more things if you want to help me with that. Here's a little showing you how to do it, and then here's a line of code that'll do it for you and tell you what those numbers are. Okay, I have been trying to, I'm a little bit psycho, and I've been trying to teach computer programming from the middle of the Pacific Ocean. I need to get connected a little bit to other people, and I've been talking recently this Hacker High School thing, where they teach kids security awareness for teens and whatever, and logical reasoning skills and the STEM kind of stuff that's so important these days. And they've got 1.4 million users they're looking at. They want to teach some programming, and they're talking, maybe they're going to hook me up with them so I can teach some computer programming to them and teach them APL.
How many users did you say they have?
They have 1.4 million people going to that website. There's a bunch of lessons there that are really pretty good. They teach you like how to Google carefully and Google academic sites and not just get garbage back, and a lot of logical reasoning skills. So they're very interested in what I'm doing.
I think it's scary for teaching hackers APL.
Yeah, I was very worried about it. They are extremely ethical, and I think if we leave it open, a certain percentage of kids are going to go the wrong direction. So we need to address this issue and put them in an ethical direction. So I'm really kind of very impressed by this site. But I was nervous at the beginning for sure. But okay. Oops.
We also teach them about Statistical security awareness, and so you had something that was called Data for Dummies.
Oh, yeah. I'm sorry. I passed that one over. Yeah. There's a thing called the optimal stopping strategy. Okay, and it applies to all kinds of things. You know, if you're going to buy a new car or you're dating or whatever, and there's some simple code there that shows you if you have a dating pool of 100 people, how many of those should you date before you say, I'm going to marry this one? Okay, or buy this car or whatever. Okay, so anyway, it's one that they found interesting, and let's see. Okay, so we're all done here, but please contact me. There's my email address. If you've got any ideas of things, you know, that would be good for introducing students, I would really appreciate that, or any hints or tips. Thank you.